does that have a common difference or ratio? So you can circle your answer. The second one, a geometric sequence has a common difference or ratio. Again, circle your answer. Number 3, can you figure out, is the following sequence arithmetic or geometric? So does it have a common difference or ratio? So decide which one it is, and if it's an arithmetic sequence, find the difference. If it's a geometric sequence, find the ratio. So I'll give you a little bit of time to figure that out, and then I'll let you know what the answers are. Right, the answer for the first one, an arithmetic sequence has a common difference, and a geometric sequence has a common ratio. This sequence right here is geometric, and the reason is it has a common ratio. If you take any term and divide by the one before it, you can get the common ratio. So 0.5 divided by 1 is 0.5. 1 divided by 2 is 0.5, 2 divided by 4 is 0.5, and so on. So the common ratio is 0.5 or 1/2. Right, in class we'll do an investigation, but since you're not in class, we'll skip that and look at the rest of the notes. Okay, so here are the class notes. The first thing we define is decay versus growth. You may have already talked about this first semester, but we'll review. Decay is when something is decreasing. An example is the height of a bouncing ball as it bounces over time. That's an example. A bouncing ball, the height of a bouncing ball, I should say. And if it's decay, your common ratio is between 0 and 1. All right, so here R stands for your common ratio. Then we have growth. An example is the amount of interest you earn. So interest in a bank account over time. And with growth, the rate is bigger than 1. Okay, so now we're going to practice writing recursive rules for word problems. Let's start with this first problem. The value of your car depreciates or gets smaller as it gets older. Suppose your car loses 1/5 of its value each year. Write a recursive rule or formula to find the value of the car when it is 6 years old if it cost $23,999 when it was new. So first of all, is this growth or decay? So for most cars it's decay, it's going down, depreciates. Now if your car loses 1/5 of its value, let's change that to a decimal. So 1/5 is 0.2. If it loses 1/5, it's still worth 4/5 or 80% of its value. Okay, so here's the equation. Start with your starting value. All right, so when you first bought your car, it's $23,999. And the recursive formula is you take the year before, and it's worth 80% of the year before. So here's our equation. So we can type this into our graphing calculator to figure out the sequence. So let's start by typing our 23,000. There's our starting value, hit enter. Okay, now for the recursive formula, whenever you see use of n-1, that's like using your answer key. So if you hit second and the negative sign, there's our last answer, and we're going to multiply our last answer by 80% or 0.8. Okay, so after 1 year, here's how much it's worth. Okay, and this asks, find the value of the car when it's 6 years old. Okay, so here's after 1 year old, 1 year, 2, 3, 4, 5, 6. Okay, so after 6 years, your car is still worth $6,291.19. So we're going to say that after 6 years, the worth of the car is $6,291.19. Alright, so there's the first problem. One more problem. So let's say Daniel deposits $2,000 into a mutual fund that pays 7% annual interest, compounded annually or every year. When does the original deposit double in value? So first of all, is this growth or decay? He's gaining interest, so it's a growth. So first step, change this to a decimal. This will be 0.07. But remember, if it's growth, it has to be bigger than 1. So this is going to actually be, we're going to use the 1.07 because it's 100% of the year before plus 7%. So here's our equation. The starting value is 2,000. The equation is for any year, you take the year before, multiply it by 1.07. So there's a recursive sequence. Okay, again, we can put this in the calculator. So let me clear this. Alright, so start with $2,000, hit enter. And we'll use our answer key to represent use of n minus 1. We're going to multiply that by 1.07. Okay, so we want to find out how many years it takes for our value to double or to be $4,000. So every time I hit enter, that's another year. So here's 1 year, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, so between the 10th and 11th year, by the 11th year, you've doubled your money. So this takes 11 years. Now, if you remember from a previous chapter, we've looked at how to solve these as well. So let's review how you can write this exponentially. So we would write y equals our starting value, $2,000, times 1.07 to the n, where n is number of years. If you want to figure out how long it takes for your money to double, $4,000, we can set up this equation. Alright, to solve this, we want the base and the exponent by itself. So you divide each side by 2,000. So you have 2 equals 1.07 to the n. Remember, if your exponent is a variable, you can use logs to solve. So I'm going to use this up here. Alright, if I write this in log form, it's log base 1.07 of 2 equals n. Use change of base. So on your calculator, type in log of 2 divided by log of 1.07, and that gives you the answer. It's about 10.24 years. So here's the exact answer. Here's the answer we got recursively. So very close. And that's it.